Hey there, chemistry folks. We're here to talk about solutions, and even if you don't like chemistry, you deal with solutions every day. So you always start with a solute, and you add that to a solvent, and you get a solution. Now you could be looking at adding a solid to a liquid to another liquid, a gas to a liquid, or maybe even just a gas to another gas. These are all solutions, but we're generally going to deal with liquids because those mix together really well to help our reactions take place. Let's take a look at a couple examples. First, I'll use as my solute chocolate syrup. As my solvent, I'll use milk. Now as I make this solution, I kind of follow a little chemistry tip where I always add a little bit of the solvent, then a little bit of the solute, stir it up, get it to dissolve, and continue adding solvent to the level that I wanted to get it to originally. You may have also seen Mio, a concentrated liquid solute that you use to make a drink. I'll put a little water in, add the Mio, the solute, and then continue adding some more solvent to get the solution correct. Next, everyone's a fan of Kool-Aid, and we'll follow the same process to make our solution. And last but not least, we'll make a saltwater solution where salt is the solute, water is the solvent, and we make a saltwater solution. So when we get to the end, we have 4 solutions that we've made, but we have to ask ourselves, are these concentrated or dilute? Now those terms are very relative, so I figured I'd put them to the test and see what I thought when I drank them.
Concentrated. Concentrated. Dilute. Concentrated.
Now my son, who had just woken up, found it quite humorous to watch me drink the salt water, so he wanted to give it a taste test as well and see if he could do it with a straight face. He was successful.
Concentrated.
Now my daughter had no idea what we had been doing, but as she walked in the room she heard her brother say,
All of them taste so good.
and I encouraged her, sit down, let us know whether each one was concentrated or dilute. Unfortunately, she trusted me, as she had no idea what was in that last bottle. Now the terms concentrated and dilute are great to use in everyday language, but in the world of chemistry we need to be more precise. We have the term molarity, which is concentration using math. You are able to calculate molarity by taking the moles of solute divided by the liters of solution. Sometimes we just do it with a big M equals moles over top of liters, but don't forget that moles goes along with the solute, and the liters needs to be solution. It's not how much water you use, it's how much the solution is total in the end. So let's say we have a situation where it says make 0.6 liters of a 0.1 molar NaCl solution. If I were to have to do this, I would go ahead and set up my 0.1 molar NaCl solution on the left. That would be equal to an x variable on the top, I don't know my moles of solute, over top of my liters of solution, which is 0.6. Then I'd do my algebra, I'd take the left side, place it over top of 1, and cross multiply. When doing this, I would end up getting an answer of 0.06 moles of NaCl. With this information, I would now need to turn my 0.06 moles of NaCl into grams of NaCl and do a mole problem. I'd use the molar mass of NaCl, which is 58.5. My moles of NaCl on the bottom and the top of the fraction would cancel out, and I would end up getting a final answer of 3.51 grams. That's how much salt I would need to make this solution. Now to actually make this, first I'm going to measure out the solid, or the solute. Next I'm going to pour water into the beaker. I want to add enough water to dissolve the solute, but not close to the total desired. I still want to be able to add that solute and not go over the line. Next we'll pour in the solute and stir to dissolve. And next we'll add enough water, or solvent, to bring it up to the total desired level, 0.6 liters. And there's one final set of terms we can use when describing these solutions. For this situation, we would call this solution unsaturated. It could hold more solute, whereas if this solution were saturated, we would say that it was holding the most amount of solute that it possibly could.
So that leads us to here, a solubility table of salt and sugar. We've been working with salt, and this line actually does go up. It doesn't look like it goes up much, but it does. It's not very dramatic. So let's take a look at sugar. It'll be easier to see what I'm trying to point out to you. Over on the x-axis we have temperature in degrees Celsius. On the y-axis we have the grams of solute that will dissolve in 100 milliliters, or grams of water. They're the same thing. And you can see, as we turn up the temperature, more and more sugar will dissolve in the water. But if you're at 40 degrees right here, and we go all the way up here, The most sugar that you can dissolve in there is probably about 240 grams. You can dissolve 240. If you have 240 in there, it is saturated. If you were to have 200, that'll dissolve in there. That's unsaturated. If you were to have 150, that will dissolve. That would be unsaturated. If you tried to dissolve 300, it's not going to work. You're going to have, right here, these 60 grams that just pile up on the bottom of the beaker. If you wanted 300 grams of sugar to dissolve, well, you better turn up the temperature up to about, 65 degrees. When it turns up to 65 degrees, you will be able to dissolve 300 grams of sugar, and at that point it will be saturated. Anything less is unsaturated. We'll talk about above the line later. So whenever you're on the line, that's the saturation line. That's the exact amount of solute that can dissolve in that amount of solvent at the current temperature.
And anytime you're under the line, you are unsaturated.